program address register and buffer, PC incrementer, program counter, and DPTR. Okay, DPTR is a data pointer which is represent the particular memory. For example, move a comma DPTR at DPTR, like that we are giving instructions. So DPTR represent the particular memory as a pointer. Okay, if example DPTR represent the 4000 means 4000 act as a address, then 4000 address value will be sent to the accumulator. Then program counter, already we know that which is store the address of the next instruction which is going to execute. Next PC incrementer, that is program counter incrementer. For every instruction execution, the program counter value will be increased by 1 byte. Then program address register. So it is stored the program address, that is for example starting address 4000 means it will store the program address. So like that store. These are the 16-bit data processing. Then finally we have input output ports. So in 8051 we have 4 types of 4 input output ports which can use as input output ports as well as in the multi-purpose ports. Okay, so port that is having drivers and latches. So drivers and latches required to convert the data between the input output devices and processor, because processor access only the machine ports. So we need to convert the drivers. So we need to know we require drivers for converting the data. So that we are using for each port we can connect the 8. For each port we can connect the 8 devices. Okay, totally we can connect 32 bits, 32 devices in theoretical, but real time we cannot connect 32 devices. Okay, but but theoretically we can connect the 32 input output devices. This is the concept. Okay, so then timing and control unit and instruction register, which is produce the control signals like ALE, reset, read and write operations. So like that we discussed. So that is will produced by the timing and control unit. This is the oscillator for generating the clock pulses. Okay, so this is the complete architecture of 8051. So special function process, that is DP data pointer high, data pointer low, that is represented by the address. So already told that each register which is represented by the 8-bit address. 8-bit address. Okay, that is data point register only by address is addressing possible. Same as interrupt enable, interrupt priority, serial input output buffer, SCOM, that is serial communication control, timing control. So timer 0, that is lower byte, timer 1 higher byte, timer 1 lower byte, timer mode set. Okay, these are controlling register which is used in the microcontroller. So 8051 registers, we have accumulator and B register, then program status word, PSW, then SP stack pointer, PC program counter, DPTR data pointer, and input output registers P0 to P3. Okay, otherwise we have serial data buffer register, timing register, power and port control, interrupt control register, timer control register. So these are the registers available in 8051, that is AB, so R0 to R7, then DPTR and program counter. So DPTR we can use as a DPH as well as DPL for 8-bit processing. Okay, this is the complete architecture of 8051. Let's take a look for any process. So in this architecture, we have buffer for save the data. Okay, for a particular time period for giving the particular delay, because we are going to connect the external devices, input output devices. So faster and slow devices concept, we need to define the buffer. Okay, next is serial input output control. That is serial input output control done in the 8051 for serial communication. So this is controlled by the S mod, that is serial mode controller registers. Okay, this is the main in 8085 they are using the most of control register format. 8085 work in a 5 volt concept and 6 megahertz operational operating frequency. Okay, why we are using 8-bit register as a special function register? That means, so every register represented by the 8-bit date, 8-bit address. For this purpose, we can access the register from the internal memory. Okay, so we have a more clarity on the execution process. So control operations will be high. So in this 8051, so output, that is termination process will be undefined loop. That is they are using S jump dollar symbol. They are using for unconditional jumping. For repeating process, they will execute it in the output. Okay. Then they are using latch in the port. So this is also uh, for used as a buffer. Okay, same port 1 and 2 and 2 and 3 are used as a address and data bus. Okay, so already said that is ports are used for different, that is multiple operations. So for input output operation, they act as an input output device, input output port. So remaining operation will act as a address and data bus. So this is the concept of ports available in the 8051. Okay. So this is the 8051 complete architecture. So in this chapter we discussed, so what is 8051? So what is the difference between microprocessor and microcontroller? So what are the basic elements of 8051? Then features of 8051, then architecture of 8051 we discussed. Okay. This is the one of the important question in this unit for 8051 internal architecture. Okay, thank you. So remaining we will see in the next class. Next class we will discuss about the 8051 pin diagram as well as programming of microprocessor and microcontroller. Like that we discussed. Thank you.